Hello learners, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this video tutorial, I will be discussing about on how to use a LM35 temperature sensor and how to display its value in a 16x2 LCD. So I strongly recommend you to look at my earlier videos on basics of 16x2 LCD and how to interface a 16x2 LCD with a Arduino Mega Board. And also I recommend you to look at other earlier tutorials on basics of ADC in your microcontroller and on how to use a ADC and display the values in a LED array. So please have a look at these videos I specified here, so it will give a better understanding of this program which we are going to implement right now. So here, as I said, in this we are going to use a LM35 temperature sensor, and this LM35 temperature sensor will measure the temperature and it will give the output in terms of a voltage. So here you can see a LM35 which is a 3-terminal device. So when you put the flat surface towards you and the pins pointing down, it can be numbered as pin number 1, 2 and 3. And pin number 1 is a supply voltage where we can give a voltage of about 4 to 30 volt can be supplied. And pin number 2 is your output voltage. It depends upon your current temperature which we are measuring. And the pin number 3 will be the ground terminal. So if I see the features of this LM35 temperature sensor, it has a linear output with plus 10 millivolt for every degree centigrade. For example, if the current room temperature is 30 degrees, then the sensor will give me a value of 30 into 10 millivolt, which is 300 millivolt as an output. So if the room temperature is 35 degrees, then the sensor will give a value of 35 into 10 millivolt, which is 350 millivolt as an output. So we can use this sensor to measure a value from minus 55 degree centigrade to 150 degree centigrade. And we can have an accuracy of about 0.5 degree centigrade when it is operated in a room condition at 25 degree centigrade. And as I said, this sensor can work with a supply voltage of 4 volt to 30 volt. So we can connect this LM35 temperature sensor to an Arduino Mega Board. As you all know that this Arduino Mega Board has a 10-bit ADC. So 10-bit ADC in the sense, after the conversion process, we will get a 10-bit result. And the ADC also supports 16 analog channels and it is named as A0 to A15. So we need to connect the LM35 temperature sensor to the A0 pin. So which pin of your LM35 will go to A0? It will be pin number 2. Pin number 2 will be connected to the A0 of your Arduino Mega Board. Then after the conversion process, we can display the value in the LCD. So for LCD, we have 3 control lines and 8 data lines. So here we are going to use the LCD in a 4-bit mode. So I use only 4 lines, D4, D5, D6, D7. So D0 to D3 will be grounded. And this D4, D5, D6, D7 is connected to pin number 5, 4, 3 and 2 of your Arduino Mega Board. And as I said, we have 3 control lines. RS is register select, RW bar is read write operation and enable is another line. So RW bar read write operation, that line will be grounded because we are going to write the data to your LCD. So we are not going to do any reading process. So we are always going to write the data. So RW bar control line will be grounded. So other 2 lines, register select and enable line will be connected to pin number 11 and 12 of your Arduino Mega Board. So to have more information about this control lines and data lines, how to configure the LCD before using it, for those information, I strongly recommend you to look at my earlier video on basics of 16x2 LCD and on how to interface the LCD with your Arduino Mega Board. So once we have connected the LM35 temperature sensor and it needs to be converted into a digital value. For converting purpose, we need to know the resolution of your ADC. Since I already pointed out that we have a 10-bit ADC in your Arduino Mega Board, so its resolution can be computed using this formula. V reference divided by 2 power n minus 1. So V reference is a reference voltage required by your ADC. So if I use a reference voltage of 5 volt, which is 5000 millivolt, and since it is a 10-bit ADC, n value is 10. So we can get 5000 millivolt divided by 2 power 10 minus 1, which comes about to be 4.88 millivolt. So this is the smallest voltage change which we can represent as a proper binary bit pattern. So that is nothing but the resolution of your ADC. So in order to have some visualization on this ADC, so if my ADC value is 512, okay, so ADC value is a 10-bit value, so it can range from 0 to 1023. Let us assume that we have a value of 512 after the conversion process. So we know the ADC resolution for a reference voltage of 5 volt, it is 4.88 millivolt. So the measured voltage can be calculated using 512 into 4.88 millivolt, it comes about to be 2499 millivolt. So that is how we can compute the measured voltage. So then this measured voltage can be converted into a degree centigrade, because we already know that for every 10 millivolt variation, it is related to 1 degree centigrade variation. So for 1 degree centigrade variation, there will be 10 millivolt as an output. So now for this program, we are going to use Arduino IDE to write the embedded C program, and to create our circuit and check the logic of our program, we are going to use a Proteus 8 simulator. So now let us dive on to doing the programming part as well as the circuit design part. First, let us create a new project in Proteus 8 environment. I am going to location where I am going to create a new project. So I will name it as ADC LCD. And in this folder, I am going to save my project files. And I am going to give a name for the project as ADC LCD with an extension of .pdsprj. After selecting a location and after selecting a file name, let me press next. First thing is we need to select our schematic where we are going to build our circuit. So for that I am going to select a default schematic, press next. We are not going to do any PCB layout, so I am not going to use this option. Next. Then we are not going to use any firmware. Next. So as a summary, you can see only the schematic layout has been selected. Other PCB and firmware is not selected. We can press finish. So here in this blue window, blue box, we can build our circuit. So in order to build the circuit, first we need to select the components. For selecting the components, I go to pick device, select type Arduino in the keyword, double click on it, it will get added to your list. Then I require a 16x2 LCD, so let me type LCD. So here you can see LM016L is a 16x2 alphanumeric LCD. So when I double click on this, it will get added to your list. Then I also require a LM35 temperature sensor. So I type LM35. So you can see a precision centigrade temperature sensor, which can measure from -55 degrees centigrade to 150 degrees centigrade. Here also you can see the symbol. So 1 is your supply, 3 is a ground, and 2 will be the output of your sensor. So this can be connected with your list. So once we have selected all the components, I can press OK to come out. Now we will make use of these components to build our circuit. So first let me put this Arduino Mega Board into our schematic. Then I am going to connect the LM35 to the A0 pin of your Arduino Mega Board. So LM35 I have selected, and I am going to connect this Vout pin to A0 pin of your Arduino Mega Board. Then I need to connect a supply to pin number 1. For that I go to terminals mode, select power, connect it to pin number 1 of your LM35, and pin number 3 should be connected to ground. Again I go to terminals mode, select ground, put it onto your schematic. So connect this to pin number 3. So that completes the input part. Now we need to connect the output part. So for connecting the output part, let me go to components mode again, select the LCD, place it onto our schematic. So here we are going to connect D4 to D7. Where we need to connect? We need to connect D4 to D7. D4 should be connected to pin number 5. D5 to 4, D6 to 3, and D7 to 2. So we try to connect in this way. So D4 will be connected to pin number 5. D5 will be connected to 4. D6 will be connected to pin number 3. And D7 will be connected to pin number 2. So that completes this part. D4 to 5, D5 to 4, D6 to 3, and D7 to 2. Then we have to connect 2 more lines. RS should be connected to pin number 12, and enable should be connected to pin number 11. So for that again let us go to the Proteus. So RS, so let me just move this little bit above so that we will get some spacing to put our lines. So RS is connected to pin number 12, and enable is connected to pin number 11. So remaining lines D0 to D3 we need to ground it. So for that I go to terminals mode, select ground, put my ground in the schematic, then connect it to D0 to D3. Same way as I said earlier, this RW bar pin also we are going to do write operation. So write means we have to ground it. So for that this RW bar also let me connect it to RW bar. I am going to connect it to your ground line. Same way VSS also I am going to connect it to ground. VEE is for contrast adjustment, and if I connect it to ground then I will get a high contrast. So the contrast and variation we can't see in the simulation part, but when we try to use it in a real time hardware you can see the variation in the contrast. So right now I am going to connect this VEE also to the ground line, and one more pin is left out, VDD, which we need to connect a supply. So again go to terminals mode, in terminals mode select power, connect this supply to your VDD line. So that completes our circuit part. So we have connected the sensor, LM35 sensor, and we have also connected the LCD to your Arduino Mega Board. So let us save this project. Now let us go and write the embedded C program so that we read this sensor value and display the value onto your LCD display. Okay. So in a Arduino, we need to first include the header file for using our LCD display. So our header file is liquidcrystal.h. So this should be included in our program to make use of the libraries functions related to your LCD. And after initializing this liquidcrystal.h, we try to use it in our program. So liquid crystal, and we give a name for our LCD. So this is a user defined name. So it can be anything. So here I have given LCD as a user defined name, and I have specified the pins which needs to be connected. So first pin is 12, which is nothing but your RS, 11 is enable line, then pin number 5 is nothing but D4, pin number 4 is D5, pin number 3 is D6, and pin number 2 is D7. So here I have given the pin details where we need to connect the LCD to your Arduino Mega Board. Then we have initialized a variable with the integer data type sensor pin, and it is assigned with the value of A0. Same way I have taken another 3 variables called as sensor value, and it is initialized to 0, MSB initialized to 0, LSB initialized to 0. So these are the variables which we will be using in our program. And the first variable is nothing but for our pin assignment. Then we start with the program of initialization of our LCD. So for initialization, we make use of this void setup function. So this void setup function will run only once during the execution of the program. So it is mainly used for configuration part. So we try to first initialize our LCD. So in order to do that, I use LCD.begin and I give what type of LCD we are going to use. We are going to use a 16x2 LCD. So we specify it as 16,2. Then second thing is we are connecting a LM35 temperature sensor to pin number A0. So this pin number A0 should be configured as an input pin. So for doing that, we use a function called as pin mode, and I define the sensor pin. Sensor pin is nothing but this A0 pin, and it is configured as an input pin. So this defines our hardware configuration of our circuit. So now we will go to the logic part on reading the sensor value and displaying it onto the LCD. So to do that, we go to the loop function. So in the loop function, first thing we are going to do is we are going to read the value in the sensor pin. So sensor pin is nothing but A0, and A0 is connected to your LM35 temperature sensor. So we read the value, and the value is an analog value. So we use a function called as analog read. So and after reading this, we will get a 10-bit result. So the 10-bit result will reside in the variable named as sensor value. So this 10-bit value can be any value between 0 to 1023. So in order to convert this 10-bit value to an actual voltage information, what we do here is we use the ADC value, converted value, multiplied by its resolution of the ADC. So we already know that if I use a reference voltage of 5 volt, if I use a 10-bit ADC, then the resolution will be 4.88 millivolt. So I try to multiply the sensor value with the 4.88 millivolt to get the measured voltage value. So for example, let us take, if I have something like a 30-degree room temperature. So 30 degree, its corresponding a 10-bit value will reside in the sensor value. When I multiply the 10-bit value with 4.88, I will get 300 millivolt as a sensor value output. So now this 300 millivolt should be displayed. In order to display it, what we are going to do is we are going to separate the value before decimal point and after decimal point. So in order to do that, I am going to take sensor value divide by 10. So if it is 300, 300 divided by 10, it will be 30, and 30 will go to your MSB part. Then in order to get the remaining, so 300, so 30 we have got, and we have to get one more 0. So in order to get that 0, we use sensor value mod 10. Sensor value mod 10. Mod operator will give the remainder, whereas slash operator will give the quotient, mod operator will give the remainder. So 300 divided by 10, the remainder is 0. So 0 will come to your LSB part. So for example, let us take the room temperature is 35.5 degrees. In that case, our sensor will give for every 1 degree 10 millivolt as an output. Since it is 35.5, we will get 355 millivolt as an output in the sensor value. So 355 millivolt, I try to divide it by 10, so I will get 35. So 35 will reside in MSB, and when I do 355 mod 10, I will get 5. So the 5 will reside in your LSB. So 35 is in MSB, 5 is in your LSB. So we try to put this value onto the LCD. So in order to do that, first we need to define the position where we need to start our display. So as we know that in the 16x2, we have 2 rows. In each row, we can display 16 characters. So I am going to use lcd.set cursor function to 0, 0. 0, 0 means first row, first position is selected. And in that, from that position, we try to print the value temp. So this is the string which will be printed in your LCD first. So it is enclosed in a double quotes. So after this temp, I am going to print my MSB value. So MSB, we know that we have 35, which means temp colon, it will get 35. Then I am going to put a dot. So dot also is enclosed in a double quote since it is a string operator. And then I put the LSB part. Now what happens? Temp colon 35.5 comes. And then last I am going to put the C part. So C is for centigrade. So finally, when I complete this code, you will get a display of about temp colon 35.5 C will be in the display. So we try to retain this value for 1 second. After 1 second, I clear the value and again we go and read the sensor data and repeat the process again and again. So that is how we can display the LM35 temperature sensor value in your LCD. So let us save this program. So I will put it as LCD temperature sensor.c. Save. So once this is done, let us compile it. After compilation, we can do the conversion of your embedded C program to a binary file. So export compiled binary. Go to Sketch, export compiled binary. It will create the hexadecimal file. So you can go to the location for visualizing it. Here you can see LCD underscore temperature sensor. Here we have the hexadecimal file. So let me open this using a notepad. You can see this is the hexadecimal file related to our embedded C program, which we are going to put it onto the program memory of your microcontroller. So once the X file is created, we can go to Proteus 8. We need to import that hexadecimal file into the program memory of your Arduino Mega Board. So to do that, right click on the Arduino Mega Board, edit properties, select the program file. So go to that location, select the hexadecimal file, open. So now it gets imported into the program memory of your Arduino Mega Board. Press OK. So now we have imported our circuit. In order to check the logic, go to the left side, bottom, you have a play button. So there you can press the play button and you can see right now the temperature measured by the LM35 is around 27.3 degrees centigrade. So that is displayed in the LCD. So if I try to increase the value, you can see the corresponding, you can see the variation in the temperature value in the LCD also. As I start increasing the temperature, you can press this upward arrow or downward arrow. Thereby I can either increase the temperature or I can decrease the temperature. You can see there is a corresponding change in the temperature shown in the LCD part. So in order to stop the simulation, we go and press the stop button. So in this tutorial, we have discussed about on how to read a data from a LM35 temperature sensor and how to display it onto a LCD, which is configured in a 4-bit mode. Thanks for watching. Please subscribe for more technical learning. Thank you.